1, boom, and you're live. What's up, guys? This is Andy, you're on Algopedia, and yeah, today is a very special day because this is going to be not only a lesson about informatics and competitive programming, but a lesson about mindset. Because as most of you probably know, I had a terrible round. I had probably the worst contest that I've had in a very long period since I restarted to solving Codeforces. So yeah, let me give you some context if you don't know what I'm talking about. So basically, if you take a look at my submissions, I've solved A and B. Let's hope at least them are going to be accepted, and I didn't even manage to solve C. So yeah, sometimes you win, sometimes you learn. I want you to pay attention to me because first of all, I'm here with a big smile on my face because I know, like in life, most of the things, especially very competitive things like competitive programming, are a marathon, not a sprint, right? So you really have to kind of balance your attitude and your responses, right? Because I've had some live streams, as you know, where I was really happy, and some guy really told me that I'm overreacting, and I might have been, but you should really appreciate and congratulate yourself for your wins, but don't be too hard on yourself for your losses, because at the end of the day, at the end of the year, it's just one contest from the hundreds that you are going to compete in. So take the lessons and move on, right? So this being said, first of all, you're on Algopedia, guys, so show me some love. I show you some love. Hit the subscribe button, hit the like button, hit the notification bell, share it to your friends, share it to all your competitive programming buddies, and yeah, come on, let's solve A and B together, and then let's see some ideas. If you have some ideas for problem C, which I didn't manage to solve, you are very welcome now that the contest is finished. I see a lot of you who managed to solve C, so please write the ideas here. So I'm gonna take a look at them, and maybe I got the final idea or something, and I'm gonna start with my bad idea, see how I was wrong in my approach, and let's see how what we should learn from my failure, right? So okay, please, first of all, don't spam the chat, right? Some of you are really friendly and good guys. Don't spam the chat with AAA, because you're going to get blocked someday, and I don't want that to happen, but let's have a nice experience for everybody, right? So let's see, one more refresh. A is accepted, so I should start with A. Cool. So first of all, I want you to see that part of my failure was that streaming. That was the one. Start streaming. Okay. Let's see. 3, 2, 1. Come on. Are we back or we are back? Tell me we are back. Come on. Show me some fingers. Tell me we are back. Come on. Done. It's okay. Finally. Yeah. Yay! It's working. Wow. Such a special day, guys, right? Such a special day, right? First, my Codeforces round freezes and I can't solve problem C. Then the live stream freezes, so I can't live stream anymore. But yeah, this is what champions do, right? They show up no matter what, man. No matter if your laptop freezes, no matter if your rating freezes or goes down, you just gotta show up. Suit up and show up. Good. So I showed up. Alright. Sorry for that, guys. It was a technical problem, like my laptop entered in memory segmentation fault, and yeah, it stopped. So, alright. It was a special day. Let's continue with problem A. Let's make it even more special, guys. Let's end the day with a smile. So, as I was telling you, this round started really bad for me because even in problem A, I've had, like, on the third submission, I was able to get accepted on it, and I think it was something like 20 minutes that even took me to solve problem A. So, most of you know problem A, right? You are given an array of n integers and you are given a number x. And what you should do is really simple. I love this statement. It's very short and concise. You have to find the longest subarray from this array which has a sum that isn't divisible by x, right? So has a sum that's not divisible by x. Alright, what I've done here is that I was very confident in myself, and I've like read the statement in 1 minute and then I started coding because, come on, it's a simple partial sums problem. Well, it's not, because, I mean, yeah, you can solve it with partial sums, of course, but yeah. So basically in my mind I was trying to count how many of those are there, and on my first submission I was even, I don't know if in my first submission, oh no, my first submission was already solving the problem. Alright, so after misleading the statement, my point is that what I did is that I thought about like this. Alright, so I have to find the longest subarray with that sum. Cool. What about the whole array? I should first see if the whole array has a sum which is not divisible by x, right? So if the sum of the whole array is not divisible by x, that means the whole array is the answer. And of course it's the longest subarray, right? So this is the first thing that I do. I just computed the sum of the whole array and checked if that sum is divisible by x. Now, if that sum is not divisible by x, what should I do? And my first idea, which was wrong, was that I take the whole array, and if this sum is divisible by x, so the array is not valid, I should subtract either the last or the first element, right? So if the last element or the first element is not divisible by x, if I subtract it, that means the rest of the numbers will have a sum not divisible by x, so everything's alright. But there was a problem with this approach, because I haven't thought, again, I was in a hurry, right? This is basically where I failed the contest, because I was in a hurry from the start, which is not good. I kind of panicked, I guess, so yeah. Basically, I haven't thought about the case in which maybe both numbers, the first and the last one, are divisible by x. Which one of them should I subtract? I don't know. I can't subtract both of them, because that could lead me to a non-optimal subarray. So what do I don't know? I really don't know. And then the idea struck to me, and it is something like this. Let me do again the Photoshop. So I hope the chat is good. Here is the partial sum approach. Thank you, boss, you are back again. Yeah. Thanks a lot, guys. I think Bunicu, I don't know, man. If Bunicu is a former, I don't know. I know two guys which are nicknamed Bunicu, which one is my former colleague from like the first 4th grade, and one of them is actually one of the best comparative programmers in Romania, so I'm honored if in any other case. It's cool. So thanks, salut Bunicu. So let's get back to it, right? So I have the whole array, right? And if the sum of the whole array is divisible by x, what does it mean? It means that instead of choosing the longest subarray with sum non-divisible by x, I thought about the other way. I thought about, I should choose some elements from the prefix and some elements from the end, like a prefix and a suffix, such that the sum of the elements in the prefix plus the sum of the elements in the suffix together give me a sum which is also not divisible by x. Because if the whole sum is divisible by x and I subtract a sum not divisible by x, of course this sum is also going to be not divisible by x. So at this point I'm thinking, alright, let me get as few numbers as possible from the first and the end of the array such that their sum is not divisible by x. So how would you get the smallest possible numbers of elements that are from prefix and from suffix? First thought that I had it was, what if I take elements only from one of these two? Should I always take elements both from prefix and suffix? Or can I choose I will take elements from the start, or I will take elements from the end. And the answer is that I get to choose. And we will see exactly why. So what I did basically is that I thought about this. If I can pick some elements from here, from the start, and pick some elements from here, from the end, such that their sum is not divisible by x, this means that at least, let's call this S1 and this S2, right? So the sum of the elements I've picked from here is S1. The sum of the elements I've picked from here is S2. And S1 plus S2 is not divisible by x. Well, guess what? Guess what? If S1 and S2 would both be divisible by x, their sum would not be divisible by x. So this means that when I add two numbers and it gives me a non-multiple of x, one of these numbers is for sure a non-multiple of x. Every time. Every time one of these numbers is a non-multiple of x. So I don't have to take into account both the prefix and the suffix. I will take into account just the prefix, right? And you can do the same for the suffix. So what I did right now is that I've made the observation basically that all we have to do is take the whole array and subtract, remove from it the smallest possible prefix or suffix that has a non-divisible by x sum. So basically, this is pretty straightforward by now, right? Because if I have to take the smallest prefix with non-divisible sum by x, I try out each and every prefix because there are at most n of them, right? So let's see what I did. In the final accepted solution, this is exactly what I did. I started with a sum equals to 0, and I've computed the sum of all the elements in this array, of course modulo x. If the sum is not divisible by x, as we've said, the array is already valid, so I just have to see out n, because the whole array is valid. If not, as we have proven, I will subtract just the smallest prefix or suffix. So, basically, I try out each and every prefix, and you will see why I've taken into account only the prefixes, because this is also quite nice. So, I start again with another sum equals to 0. The solution is initially -1, and I try out each and every length of the prefix, so the first I elements. I compute the sum, which is of course increased by a of I modulo x, and if this s is not 0, right? Sorry. So if the sum of the prefix modulo x is not 0, this is a prefix which is not with a sum non-multiple of x. So I've taken into account both possibilities. Either I keep the prefix or subtract the prefix, right? Because these are the scenarios. When you end up with when you subtract the suffix, you remain with a prefix, right? When you subtract the prefix, you remain with the suffix. So I either choose to remain with this prefix of length I, or choose to remove this prefix and remain with the suffix of length n minus I, right? So basically, the first scenario is that I subtract the suffix of length n minus I, and the second is that I subtract the prefix of length I, because both of them have a sum which is not divisible by x. So at the end, I just see out the solution. And that was A, guys. That was A. It was pretty tricky. I am very excited that I see a lot of you guys on the live. It really lifts my heart up after all this mess with the contest and with the live stream. I am happy that there were, I think, 200 Algopedians at the same time. I love you guys. I love you, and thanks for being here, right? Thanks for assisting here and being with me on my failed contest. So this was problem A, right? I think it's pretty clear, and yeah, just choose the prefix or the suffix. Come on, should we move to problem B? What do you say? Should we move to problem B? Same approach as yours, but I like the way you're just doing it for prefix. Yeah, it is pretty cool. Shout out to Octavian again. This is the second live streamer. Octavian is live with us. What's up, man? What's up, Kotza? And shout out to my dad. Hey Dad, I'm very happy to see you here. I hope I'm making you proud, or if I'm not making you proud right now in this contest, because it is a bad contest, come again on the other live stream, because I'm gonna make you prouder there. So yeah, we should continue with problem B, right? This was also a tricky problem, but I found it a little bit easier than problem A. Like, this was the paradox of the round. Maybe some of you found problem C the easiest and I failed to solve it, but yeah, problem B is quite nice. So, as you know the statement, we are given a permutation P of length n, and we should find a subsequence, which is not a subarray, right? A subsequence. The elements can be, they don't have to be consecutive, right? Can be in any, not order, but yeah, you got the idea. And we should find this subsequence of length at least 2, such that this sum, the sum of these absolute differences of each and every 2 adjacent elements from the subsequence that we have picked, is as big as possible over all the subsequences. And of course, there could be multiple such subsequences with the maximum sum. In case there are multiple subsequences, we have to pick the one with the smallest length. So yeah, the statement is quite clear, I think, and we can jump to the solution. So I will explain you my kind of thought line. I haven't thought a lot about this problem, to be honest, because I've kind of solved in my past problems very similar to that one, right? So in competitive programming and any other skill, as you know, experience and time and the hours you put in really matter and are important, right? So I've solved kind of a lot of problems that look like this one, and I know one trick about these problems that I'm gonna share to you, right? Because that's what we do, we learn from each other's. Yeah, so yeah, basically, as you see here, right, we have absolute differences of adjacent elements in the subsequence. So the thing here is that when I think about absolute differences, let me draw you something, because drawing is a lot better. When I think about absolute differences, I'm like, let's say I have an element that I pick, which is -2, then I have maybe 3, and then I have 7, right? Let's say I pick one pair of elements, like -2 and 7, right? Let's say I pick this one. When I think about absolute differences, I think about it kind of geometrically, right? I like to think about how the numbers look on an axis. And let me show you why. If I take the first number, which is -2, right? So the first number, if let's say this is the XY plan, right? So this is the XY plan, 2, 2, all right. So if let's say these X are the indices, right? So this is the first number, the second number, the third number, the fourth number, and so on and so forth, right? And on OI, I have the values. So the first number is -2. So I go -1 and -2, right? So I can draw a point that will denote my first number in the array. All right, let's go with the second one. Second one, this is 1, this is 2, this is 3. So I can draw a point that is going to denote my second value from the permutation, and or array in this case. And of course, with the 7, let's suppose 7 is somewhere here, so I can draw this point, right, which is the third element on this array. Now, what I love about thinking like this and visualizing the things, the array like this, is that the absolute difference between two elements is, of course, if you take the pair of elements, let's take 3 and 7, is, of course, the difference with this y's, right? So the difference on the y-axis, right? So, all right, this is the case with 3 points, right? If let's say I take I think I have swapped this. Alright, should be cool. It's not cool. Oh, now it's cool. Alright, so let's say I take -2 and 7. Of course, their difference is all the way from 7 to -2, right? So you kind of got the idea. Well, this can look very, I know, non-intuitive, right? And you're like, alright, Andy, why do you do this? How does it help you? It helps me when I think a lot about large arrays, right? So when I have 3 numbers, yeah, it doesn't look very well. But when I have n numbers, let's see how this array on a 2-dimensional plane looks like. Because it looks like this. Let's say this is the first number, second, right? Third, fourth, fifth, sixth, 7, and so on and so forth, right? Well, the first number is a point here. Then the second number could be greater, right? So let's say, for the example, that is greater, right? Then the third number, maybe this is greater too, somewhere here. Then the fourth number is the smallest. Then the fifth is here. Then the sixth is here. Then the seventh is here. Then maybe the eighth or something is here. Then here. Then we go here. Then maybe we decrease some more. We go here. And let's say finally, all right, we go here, right? So I imagine each and every array could be imagined like this, right? Like multiple segments, right? And one segment is basically between two adjacent elements from the array, right? So what is the beautiful thing here is that if you think like this, you are going to notice one beautiful thing. And that beautiful thing is the following one. What's the point of choosing number 1 and number 2? The first 2 elements. If I choose these 2 elements, their difference is this, right? So what's the point of doing this? When I can, of course, choose this number, because their difference on the y-axis is definitely greater than the one of the previous 2, right? That's interesting. So if I start on this point, there's no point of choosing this element. Alright, I can choose all of them, right? I can choose, let's say, in my subsequence, I can take the first one, the second one, and the third one, right? The difference is this one plus this one, right? So this plus this. But why should I do that when if I take the first and the third, I already have that difference, and I get the difference using a smaller number of elements, right? So the point is that this problem is not that hard without the second constraint. If you are just asked for the maximum sum, of course, I think you are going to pick the whole array, right? So yeah, I think that's it. Yeah, of course, you are going to do that. Yeah, of course. So if we haven't to find the smallest length of some subsequence, we take the whole array and we are happy. But when we need to minimize the number of elements, you really have to make these kind of optimizations, right? Why pick all these 3 elements when I should just pick the extremes? Then let's continue. Let's say I took the first and the third number, alright? Cool. This is the fourth one, right? Should I take it? Yeah, I should. Because this fourth number will give me, paired with the third one, this difference, which is good. If I've taken, let's say, this number and not the fourth one, this difference is smaller than the one that we obtained with the fourth one, right? So it's pretty clear that we are also going to take this fourth number, and after taking fourth number, think about this. Rapid quiz, fast quiz. Think about this. We have, let's say, chosen this number, and this number. What do you think is going to be the next number that we choose? Think about this. Well, I have to alright, my nose is clean. So, have you thought about the answer? What do I do? What is the next number that I should pick? Should it be this one? Or this one? Or maybe I should pick this one and then this ones? No. I should directly pick this. No, not this, sorry. I should pick each and every one of them. Yeah, that's not the best example. That's not the best example, but yeah, the answer was right. I should pick this one, and then this one, and then this one, and then this one, and then this one. And this example is actually more okay, because I won't pick this number because it's the same as here. I will just pick this one, right? Because why have three sums to give me the same sum of absolute differences that only these two can give me, right? So after all this drawing and explaining, the final conclusion is the following one. When I'm just increasing, and I hit a point where I'm going to decrease the numbers, I will pick the start of the hill, then I go up the hill and I pick this one. Then guess what? I move down the hill, and if this is the stopping point and then the numbers just get increased, I'm gonna pick this one with this one with this one. Then they are going to be increased, and so on and so forth and so on. I'm going to pick this one, and then they are increased, and so on and so forth, right? So basically, these numbers are called peaks, right? A peak element is an element which is strictly greater than its neighbors. This is a peak, and this is a valley. A valley is, of course, the name is very suggestive, an element which is less than its neighbors. And the answer is, you take all the peaks and all the valleys, and we will suppose that the first and the last elements are a peak or a valley. It really depends. Like, the first element could be a valley if the second is greater, or a peak if the second is smaller. And the exact thing with the last one, right? So basically, when you think about peaks and valleys like this on a two-dimensional plane, you will notice very easily that there's no point in taking these middle points, because after all, this is the difference you are looking for. There's no point in obtaining the difference using a lot of numbers, when you can just use valley, peak, valley, peak, valley, peak, and so on and so forth. So this is what I did. I just found what are the peaks and valleys from this array, and I just took the peak and valleys. And that is it. I can Corona alert. Yeah, that's funny. Nah, it's not Corona. A was an easy segment 3. Police already discussed. B, this is B, and answer. Yeah, police. I think some siren was in the background. All right, cool. So let's see the code for this question too, right? So hope you enjoyed my explanation with peaks and valleys. Maybe a lot of you solved the problem thinking differently about it. It's accepted, so yay. At least A and B are accepted. But if you haven't thought about peaks and valleys, or maybe some of you solved the problem super intuitively but didn't prove, you know, the solution. With this kind of approach, you can easily prove the solution, which I think it's quite obvious, right? So yeah, don't mind about this code. It was from some other problem. So yeah, basically what I did here is that for each and every test case, I read the array, I start the answer with an element which is the first element, because I suppose it is a peak or a valley, no matter what. And then from the second to the previous, to the element before the last, right? I just check if it is a peak or it is a valley. I just push it into the answer. In the end, I push into the answer the last element, and I just print the answer. And of course, for checking the peaks and valleys, I just have to check the obvious conditions, right? So this was problem B, guys. We have solved A and B. So I haven't seen if some of you I have some Romanian fellas right here, so yeah, that's quite nice. We have solved B. I can scroll through all those comments, but yeah, there are a lot of them. So alright, being Sebi. I don't know what kind of Sebi is this. I know a lot of Sebi, so your name is not specific enough to know who you are, but over all subsequences of P with length at least 2. Yeah, subsequences are not subarrays necessary, and they have to be of length at least 2. So, okay, guys, please, if some of you has some hint or some idea about problem C, we'll solve it. If not, I might actually look at some of my friends' sources. So cheers to one of my students which did better than me. So yeah, sometimes the student gets better than the teacher. I mean always, yeah, it has to be like this always, right? So always the student at some point has to be more successful than the teacher, even in short term or long term, but on the long run the student should be like this kind of gap between the student and the teacher, because this is how it's supposed to do, this is progress, right? So let's take a look at the source code of my student and let's try to figure out what he did here, and yeah, I shall find out how this problem is solved. So it looks like he has read the array and he has counted how many times each value appears, right? So basically have is a frequency array, and here is the answer. Cool. So what he did is that if answer of I is equal to -1, I think answer, did he initialize the, alright, cool. So he initialized the answer with -1. So basically he says, alright, I don't know the answer for no element, basically. So if answer of I is equal to -1, while half of max, and max starts from 0, is greater than 0, plus max. Alright. So basically, for each and every position, he has a max, a pointer max, which always gets increased. And as long as that value exists in the array, we were going to increase the value. And at the end, we will use it in the answer. Alright, that's interesting. That's interesting. So he starts with max as 0. And he just looks if the current max is part of the array A. We are not going to use it. We are going to increase it, increment it, until we find the max that is not part of the array. And we set the max there. Then we decrease the frequency of A. Alright, we decrease the frequency of A. Alright, this is big. So basically in that frequency array, he just has the number of appearances of each element starting from position I plus 1. Or no, starting from position I, actually. Yeah. Alright, that's cool. If half of A of I equals 0, answer of I plus 1 becomes A of I. Alright, that's interesting. Alright, that's interesting. Yeah, that makes sense. I thought about something like that too. Alright, cool. And the max is the maximum between max and A of I plus 1. Which is also interesting. Oh, this is interesting. So basically, he's like, on each, he's incrementing the max. Okay. Oh, I see. Oh, come on. Oh. Yeah. Makes sense. It really makes sense. Makes sense. Makes sense. I feel stupid. Nah, you shouldn't be stupid. Editorial is out. Yeah. Oh, it is out. That's cool. That's cool. But if it's out or not, I've already seen my student solution, so I'm gonna stick with this one because I think it's pretty cool. Yeah. All right. So let's draw a little bit and explain what he did on short. I think everybody should understand. So yeah, basically he has thought about like this, which is actually how I thought about it, but in a too complicated fashion. So he's like very simplistic about it, and he's like, all right, this array A, we are given the array A. This array can be split into sub-arrays that have the same element. So let's say 0, 0, 0, 0. Then let's say maybe we've got some 3, 3, and 3. And after this 3, because they always get increased, let's say we have some 6, 6, and who knows, 9, right? So you can basically see the array A as the union of sub-arrays that are equal, right? Basically. So all these sub-arrays have the same value. So one interesting thing that I've really noticed here, and he also did it in his solution, is that let's think about it like this. Let's suppose that we are trying, right, to figure out what is the array B. So we are trying to fill each and every position from the array B, right? So let's say we are here and we managed to find some valid values from the for the first 4 positions, right? So we have got these values, and these values have the max equal to 0. So they could be something like, I don't know, 5, 4, 2, and 1, right? Let's say we have found these values, 5, 4, 2, and 1. Obviously they are valid because for each of these prefixes the max is 0. Then the crucial point is when we move from a value to a greater one. Here we move from value 0 to value 3. What does this mean? When we switch to a strictly greater value, this means that we definitely should not have the max 0 on the first 5 elements. So the max here is 0, which means that the value 0 does not appear within the first 4 elements. And because now I want the max to be 3, this means that 0 should appear. So I should have for sure 0 here. This value is going to be sure 0. And as you can see, this is valid, right? 5, 4, 2, 1, 0, the only one missing is 3. So one observation that I've managed to do in the contest was that each time you move from an element to a greater one, the position, basically the index or the position where a value first appears for the first time, like here 3, is going to be equal in the array B with the previous element, right? So 3 appears for the first time here, this one is 0. 6 appears for the first time here, this one is 3. 9 appears for the first time here, this one is 6. And the proof you have seen, if the max until this point is 6, I surely have to fill the value 6 because I need to have it in the prefix, right? So the max is greater. So cool. So one thing that that he did was this kind of observation, right? This is exactly what he did here, right? If half of a of I equals 0, so at this point, because he is always decrementing the frequency of each and every element, at the point where the frequency of some element is 0, this means, in other words, that this is the first position that the next value will appear, right? So I think, yeah, answer of I plus 1 equals a of I. Yeah, so that's what he does, right? So when we are, let's say, here, and the frequency of 6 is 0 because it was decremented 2 times, this means that on position, this position, we will have value 6. Okay, so this is what he did, right? That's some music right there. So this is what he did, and basically this piece of code I've managed to think about it during the contest. This part I was stuck, And he was very simplistic about it, and I really appreciate it. I'm very proud of him. He's got a great solution. He was very simplistic. He's like, alright, what about the other elements? Well, what should I do is that for each position, let's say, I don't know, I want to complete this position, right? I want to find the value of B here. Well, for some value to be valid, I can't have 6 here, right? Why can I have 6 here? Because if I have 6 here, these maxes are not going to be 6 anymore. So, in other words, on some position P, I should always look at the elements on each and every position after P, and I won't have the value, I won't choose a value for B of P that appears after this position, right? Because if I choose 6 or 9 here, as I have said, I'm not going to have the max 6 here, right? Because how can I have the max of the first 8 elements 6 when the 7th element is 6? That doesn't make any sense, right? So what he did was that, noticing that here I'm gonna have 0, 3, 6, the other values are just going to be the smallest value that is not part of A of P plus 1. So for each and every position P, what I have to do is, each and every position P lies within one of two categories. Either the first category that we've talked about, when it is the first time some value appears and I know what the value should be, or the second category, if not. This means I should pick the smallest value which does not appear after position P. And that's it. So I didn't manage to solve this second scenario because I've overcomplicated myself. He was very simplistic. He's like, you know what? I think I should pick always the smallest value which is not part of that suffix. And that's cool, right? And as you can see, he's got accepted. And of course, we have to mention this solution has time complexity of big O of n, right? Because you basically start with the max as a pointer with 0, and max only gets incremented and increased. So we start with I from 1 to n, this is big O of n, and even that we have this while loop, max starts from 0 and is always incremented or increased. Incremented in the first scenario, increased in the second scenario, until it gets to the point that it's at most n, or 1 million or something like that. I think n, not even 1 million. I think n or n plus 1 is the maximum value that some value of answer could reach, right? So yeah, this was it. Really congratulations to the guy. He got it right. So I'm very proud of you, Robbie. I'm very, very proud of you. Alright, cool. So yeah, the maximum and minim editorial is out. Alright, cool guys. So I hope everything's cool. I hope you've understood everything well. I'm sorry that you can't see myself really good. Now you can't see myself at all. Alright, cool. So sorry for the light. I haven't turned the light on or something like that. But yeah, this was it, guys. So again, we are not learning here about how to solve problems, but we are learning mindsets. It was a bad round for me. My rating is going downhill, but that's not a problem because this is just a fight from the whole war. This is just a sprint from the whole marathon, and we will have other tens of rounds in which I'm going to increase my rating and do better. By now, we learn from the mistakes. Thank you for being here. I love you all. Thanks for watching. Thanks for the attention. Thanks for the love. Don't forget to like the video. Don't forget to share it with your friends. And don't forget to subscribe and hit the bell notification. And as always, come here for more. It happens that I sometimes have some periods like a week when I can't post and can't compete in Codeforces rounds because I got other stuff with university, but on the most of the Codeforces rounds I'll be there, I'll be competing, and winner, loser, there's no losers. I'm always going to share my solutions with you. Cool guys, thanks for all the love. Share, subscribe, like, and see you on the next one. Andy out.